And suddenly it gets moody in here. Good evening, everybody. How are we doing? Fantastic. Right, it's been a long time since I've been up at the front of Fusion. Actually, I don't think I've ever been at the front of Fusion. I've been involved with this thing for years now. Yeah, it's a first. And that's really surprising, because normally you can hear me all the way from the back. So, hi, welcome to Fusion. How are we all doing? It's a wonderful evening, and it's raining outside. It's terrible. Yeah. So, first things first, clicker's died on me. There we go. Who enjoyed the food from Habaneros? I'm not going to lie, there's going to be a lot of people in this room knowing they had a burrito later. Including me. Anyway, so, this is Fusion, and usually we have a short man about this high, slightly grumpy, loves Birmingham, don't know why. He's not here today. I'm giving him that clicker, it's dying. There we go. So here's a wonderful picture of him in Frankfurt, because we all need some form of joke to start the event, and my joke today is Jim. Somebody can tell me off for doing that, but I don't care. He's not here to tell me off. So, he's not here, I'm here. My name's Mike, I'm your MC this evening. I'm usually the AV guy, and I'm very loud and a little bit obnoxious. So feel free to tell me off and shout at me. Oh, Jesus Christ, clicker. There we go. So, I also happen to be, if you haven't noticed, I'm wearing a branded t-shirt. I really don't need the microphone to be heard around here. I have to work for this company. They're at Infobit. Hands up if anybody has heard of them. Whoa. Julia, we're doing a terrible job. Julia, by the way, is my boss, also from Infobit, so please ask me and Julia about the company. We are a communications as a platform service. For those of you who have no idea what we mean the other Twilio. So we send text messages, emails, and all that jazz. It's the fastest way to explain what we do, and it's really bloody accurate. So all those communications things, please talk to us about sending messages, APIs, all that jazz, blah, blah, blah. Now moving on. I believe DWP are also a new sponsor of ours, and they do have representatives in the front of the room. Hands up. Yes, I'm throwing you under the bus. I was meant to have a spiel for them, and Hannah's forgotten to share it with me, so DWP does pensions and stuff, and you're the digital arm of it, helping people deal with that online? Sorry, people tell me I must do this thing. I'm pretty sure that's the thing. I can do it again. So yes, I'm pretty sure we're all aware of DWP, and they have their digital arm here. And as usual, the events in Birmingham are not cheap to run, because Birmingham, surprisingly, is not a cheap place to do things in the city centre. So if you'd like to sponsor us, please come and talk to us. Or if you'd like to sponsor any of the other amazing events, of which I can see multiple organisers in the room, please poke them to give them money. They'd appreciate it too. And we do have the shiny website. If most of you found us through Meetup, I'm assuming, or Eventbrite. For more in-depth information and random stuff, thanks to James Vickery and his wonderful design eye, we have a website. There. And for all your social wizardry, bangery things, #Fusion Meetup on Twitter, tooting, madness, enjoy. I'm a terrible MC, I'm really sorry. And these are some of our partners. They've been around for a long while, and they do amazing work. I'm still trying to work out why we have a one-man show in the front left corner as the most important spot, but they do amazing things, and this next slide is going to drive me absolutely potty, because I feel like I'm going to have to read them all out. Thanks, Jim. So we have Tech Mids, wonderful conference. Who went to Tech Mids last year? Okay. I expect the entire room to next time it's on. If it's not, I'm going to get real loud. And then we've got, obviously, Fusion, Coffee Ops, and everybody else. Everybody doing wonderful work and helping to teach people to do things. It's great. And on that note, we do have the next set of events up. So do we have anybody from ManageOps? No, Max? Oh, okay. So ManageOps, it's been sold out every time. It's been busy every time. So if you're in engineering management, etc., they will be the 20th of March in JointWorks. Also at the JointWorks, we have the .NET Xamarin meetup doing a bunch of lightning talks on the 5th, if that's correct. I apologise, I'm going to be throwing my hat in the ring for that one, so more of me talking loudly. Once again, joint works. You may be seeing a pattern happen here. I think everybody loves the joint works. And then we've got Codebar. Ryan? So much energy! Where's it going to be? Where's it going to be?
I don't know. I've yet to ask, but possibly
Oh, okay. Keep an eye out. Ryan will be putting the link and all that jazz up to run it, supposedly. Oh, okay, so it's going to be a travel perk on the 13th still?
Sounds like a commitment.
I do enjoy throwing people under the bus. You are now committed. Enjoy. And we do also have a code of conduct. Yes, we should have our own, and we will get around to that eventually, but we keep forgetting, and then we do this and go, oh, sorry. So this is the code of conduct. The TLDR of it is, I believe I love the phrase, is don't be a jerk. If anybody is being a pain in the bum or an absolute nightmare to you, please go and attack anybody with... Well, attack is a wrong word to use, but in the context of a code of conduct, viciously attack. Please come make it aware to anybody wearing a Fusion hoodie. There's quite a few of us, and we'll deal with it. And that makes it sound even worse. Oh, God. And now for the talks. Everybody ready for those? Yeah. Okay, so we first up have Tom. Come on. Now, I'm assuming I don't need to do any introduction. You're going to be doing that yourself, even if I did ruin it.
Yeah, no, that's absolutely fine.
Move out of the way.
Check it's working. Good to go. Am I mic'd?
Are you?
No, I'll use this, which is fine. Is that working? Cool. So it's great to see everyone. I appreciate the Apprentice final is on tonight, so I thought people might be dropping out to see that. I was going to drop out myself, but I thought that would look unprofessional, so I kept to it. And if you have seen The Apprentice last week, it's when they're doing the interviews, and so they say to the candidates, you know, Alan will say, what do you want the money for? And they'll say, I want to build a sweet shop or something like that. And Alan will say, oh, well, we've got 10,000 sweet shops, we don't need that, you're fired. And it's kind of like, why does he leave that until the end of the process to tell them? Why doesn't he just do that up start? So it's the theme of getting fast feedback, which is what this talk is about. So I've been at the department for 3 years now. I joined Leeds during COVID. And you know how it is, you join somewhere remotely and you think if they're going to make you go to the office, you're going to just kind of quit. And so when they started asking me to go in, I said no, because it's too far to get to from Birmingham. And they said, that's fine, we'll build you an office in Birmingham. So this is the office, and I have the top floor. Just kidding, I'm lucky if they let me in, to be honest. But it's over by the Canal House. There's a few of us in there, so it's a bit of a startup feel. And the department has offices in Newcastle, Manchester, Leeds, London, and now Birmingham. And DWB Digital is the element that does the IT part of the department. So the department does three main things. State pension, so that's when you get to the age of 68, we'll be paying your state pension. Working age and health, and universal credit, so the benefits kind of system. And it's universal credit that I'm in. So if you ever become out of a job or you're unable to work, what you'll do is you'll get your phone or your computer, go onto our web app and sign up to the credit system. And what you'll do then is be assigned a local job centre where an agent will work with you to kind of progress your claim. And we've got 700 job centres over the UK, and 6 million claimants are using it. Under the hood, to power all that, we've got a collection of 150 microservices. So they're mainly Java-based, and we use MongoDB to do the database, and it's hosted on AWS. And it's all event-driven through Kafka. So you might get one microservice that says, this claimant has changed their circumstances. Another microservice will pick that up, do something with it, and it kind of trickles on through that. And with the calculations and payments, this system pays out around £220 million per day across the UK to claimants. So quite a lot of money is coming out of this system. And the other thing as well, so over on the left is national insurance credits. Do people here know what national insurance credits are? So when you work normally in a job, at the end of the year, you'll get a national insurance stamp, and you need 35 of these to be able to claim the state pension at the end, or the full state pension, sorry. But you also get it if you're on universal credit. So it always pays if you ever find yourself out of a job to make sure that you sign on UC to get that credit. And we did the national insurance credits microservice last year, but it was really painful to get out. This is all deployed as a mono repo, so it goes out as a set each time. And what we found is that we'd run it in production, find out there was an issue, tweak it, wait 2 weeks, because that was the deployment cadence, try it again, and it was just quite painful to get it out. So our team was asked to solve a problem, and the problem is this. In an area, you've got a set of jobs, so it could be a chef or apprentice or something like that. And then in that area where the job centre is, there's someone in there called an employer advisor. And what they're doing is they're keeping track of these jobs and speaking to employers. And they put that into a spreadsheet, which is for the current vacancies. They then circulate that through to the work coaches. And then when the work coach has a meeting with the claimant to discuss that, they might suggest a job to go on. And then the claimant then puts that, the work coach then puts that into another spreadsheet to track that they've gone onto it. So it's all a bit faffy, like the spreadsheets lock up, they're using SharePoint, it's hard to update, people forget to update it, it's all a bit naff. So the idea was to kind of digitize that and build a new microservice for it. So this new microservice had a few objectives. It would have to allow the EAs to put jobs into it. It would have to be a search engine to allow them to search for the jobs. It had to provide an initial recommendation, so something that the claimant had said they were interested in or with a skill. And it had to be location or time travel aware, so it had to know jobs that were nearby the claimant. And we have to be able to track to make sure, to see how they did, basically. And so when you're kind of starting a new microservice, it's like a little bit exciting. It can get a bit exciting. And you kind of think, what can you ram in there? What's the latest thing? You might watch Fireship on YouTube, and whatever he's talking about, you just want to ram in and see if it works. And then you kind of simmer down and you think, okay, well, are the other teams going to be able to deploy it? And yeah, we could use Quarkus or Micronaut, but we know how to use Spring, and we can just get going with Spring. So you kind of settle down after that initial phase, and this was the final stack that we ended up with. So MongoDB, because we love and trust that from the other microservices, Spring Boot still, and Lucene. So we did consider things like Elasticsearch or Apache Solr, but they take a while to get up running, and we can do most of what we want in RAM using Lucene. And also NextJs, because the front end currently is very flat. It's using mustache templates. And so we've not really got anything JavaScripty in the estate at the moment. So NextJS meant that if we push a load of React out into the job centers, it's okay if it goes wrong because we can render it all server-side if we need to be. So I'm going to give you a quick demo of this app. Is that coming up? Yeah. So this is the app, and this is where the EAs in the job center come and manage their jobs. So imagine employers are talking to them about the jobs that they have. So they can see the jobs that they've added already. There's some filters down the left, and they can click Add a Job here, and they can type in the employer. They can type in the job title. This is a real job, by the way. And then you can go down to different ones here. And so you fill out the normal kind of information that you would for a job. And then we've got a submission limit so that once it's been shown to kind of 10 claimants, it will shut off and not show anymore. And then the other part of it is the location. So you can choose remote because it might be a remote job, or you can choose on-site, which means that it has like a postcode basically. So if I put in 3 Arena Central, which is our new office in Birmingham, and the postcode, what we need to be able to do is place this job on the map. So if we just quickly go back to the slides. So if you think about a job with a postcode, how do you get the postcode onto the map? And it's pretty simple. You can download a CSV off Post Office or something like that, but we've actually got an in-house service that will translate a postcode into a lat long. So when we save the job into the index, we can save that lat long position and we know where the job is. Then, when we come to doing a search for a claimant later, we could do the same. We take their postcode, look up the lat long, and then look to see what jobs are around them, and then expand that radius to kind of capture more jobs in the area. Thinking about other sorts of jobs, like field jobs, if you think about an in-house carer, or in this case, a fraud investigator who has to cover an area, using the middle of the area doesn't quite work. So what we can do is download off Ordnance Survey a list of areas and the boxes in terms of lat longs that it covers. And then when we query it, we can say if the box intersects with the circle, then return it as a job result. So that's how you kind of, that's what's happening in the background when you save it. And then when you click field-based, you've got this auto-suggest, which again is great because we hadn't used much JavaScript before. And it will suggest areas that it knows about the boxes that I've just shown. So you kind of select an area and then you click save. So that's kind of storing the jobs. The claimant, so imagine now I'm a work coach in a job centre and I'm speaking to a claimant about a job. This is the system that they use, and they can go into, oh no, it's got me as the wrong job, just a second. So you would normally go straight in there, but something's just changed. So they'll click search for a job, and what that will do is it will bring up the search page, which is similar to what you've just seen, but with a few differences. The first, it's pulled through from the claimant profile that I'm interested in software, so it's showing the software-related jobs. And in Lucene, what you can do is you can upload synonym lists. So words like software, programming, engineering, they're all the same sort of thing, and it will automatically expand that in the background. It's also got my postcode, and it's showing me this job, which is in with 10 miles. So if you increase that to 100 miles, it will bring up jobs in our Manchester office. And so then the work coach can like look through that, discuss it with the claimant, and then when they click this button, it will go to the claimant's journal, which is their email, basically. We also then did a slight extension to this. So there's an external service called Travel Time. And what that does is you can give it the lat long of the claimant's postcode, and it will look at all the train timetables, the bus timetables, and work out where they can get to within 90 minutes. So this is quite interesting because instead of being a round circle, you've now got all these polygons. So you can see that this claimant, which is me, can get to Birmingham, it can get to Coventry and Tamworth, and that's because there's high-speed links to there, and then you can get the bus out. So we can then plug that back into the search results to kind of show results. And the other thing that external travel time will do is it will plot a route. So sometimes claimants will say, well, we don't know how to get to that job. And as well as the details from before, it also gives you the directions to get there. So it will say it's approximately 38 minutes, it's going to be about £4.20, this is the route to take, and this is like a map to get there. So that's the microservices. So that was NextJs, Lucene, and the backend. And I'm not sure if people have used Lucene, but it is really simple. This is storing a job. So at the top, if the job has a postcode, we just store the lat long on the document, and that's it. The second bit is if the job is like in Birmingham, it's creating a polygon, and it's just storing that. And that is literally the code to store the object. Then when we do a query, we do it in kind of the opposite way around, and we say, get the claimant's lat long position and give us results that are within 2 miles. Or give us results where the area intersects, and that's simply the code that's for it. So now that we had the app, what we needed to do then is deploy it. So we could deploy it as part of the existing set, as part of the existing monorepo. And that did have advantages because, you know, the process is there, there's nothing much to do. But the deployments were slow, thinking back to like the NI credits and the issue that we had there. And also we needed to get NextJS into the front end of that app. And we didn't want to be in a position where a work coach would say, we want the fuzzy searching tweaking slightly. And we say, oh, that's fine, it's going to be like in 3 weeks, and they've kind of forgotten your name by the time it comes out. We wanted to get it out quickly, so we thought we'd deploy it separately. The first step to that is extracting out the single sign-on. So all the user information and their roles were stored in another microservice, But in Keycloak, it actually makes it easy to add a custom extension to look that up, and then that kind of completely separates that. And then the next bit is just getting it into production. So we had a bit of a brainstorming session and said, what's the best way to do this? What are people familiar with? And some people said, okay, well, we can put it into dev, do a check, put it into stage, do a check, put it into production. But the issue is, who manages these deployments? And who tracks what versions in what environment? And who makes sure that it goes out in the right sequence? In the monorepo, we've got a release manager doing that. And now that we're just doing that as a team, we didn't want to kind of start repeating that sort of stuff. So we could make it a bit more simpler and say, okay, we'll stop in stage and do it just before production. But it's a bit much of the same issue, especially when you're using multiple microservices. You can deploy them all into stage, and you might have QA sign that off. But then when you come to deploy that into production one by one, you've got a different set in production that you haven't actually signed off. So that's also a little bit strange. And then the other problem is this. As soon as you put in a manual kind of gateway, it can become easy to foster an over-the-wall effect. So a developer might commit it, it's going to go into QA or stage, but then it's the QA's issue to get it up further than that, or a release manager's. So it can make it seem like someone else's problem once the developer has committed it. And if there is a problem, the developer might be onto something else by then. It also causes a lot of changes to build up. So if you think of a release that you're taking out, you might have 4 developers, they've all committed. And if a problem happens, which developer kind of looks at it? Sometimes you have a good egg and they'll kind of be the ones that are always looking to fix it. But it's harder to find out where the problem is. And then also, if production does go on fire, how are you going to deploy or get that fix into production? You can't just push the previous versions in because they're untested. So what you normally do is you fix production, you then backtrace the fix into stage, otherwise stage would revert that fix. You put it into dev, you put it everywhere else, and who wants to manage that process? And people would rather be developing than kind of doing all that. And it becomes even more complicated when you think of more microservices. So what if we get rid of all those gateways? The version that's merged is what goes all the way to production. It's fully automatic. There's no messing around with releases. There's no no-go meetings. We can get feedback from the users faster. Is this fuzzy search working? No, we'll tweak it, and we can get a fix out within the hour. And how do you get that fully automatic pipeline? So the first thing is to deploy it, to build it as a container, because then you can ship the container into each environment. And we favoured shift-left testing, so we do all our unit tests, as much testing as we can during the build and the branch. Once we push to the feature branch, we can then label that container with the commit hash. So we've immediately got a quick win because we don't need to do versions like 1.2.3. The versioning is already happening because every time we push a commit, it will rebuild it and it will rebuild the container on the branch. And once that container is ready to go, it will go green and we can push it out. Then, when we do a merge, we can just push that container out. There's no need to rebuild it on master because we'll use a fast-forward merge, so we don't recreate a commit. We just move the commits onto master. It's equivalent the same, so we can just get on with moving the container out. And then the container will make it all the way to production. But then who is tracking what what works with what? Because we need to make sure that the front end works with the back end. And we can use a contract enforcer like Pact to do that. So have people heard of Pact or are using it? Yep, one. So Pact 101, it's a simple tool to create a contract between microservices. So in our front end, we might define a contract that says, when I call the back end for this job, you're going to return me some data that looks like this shape, which is a job name and employer. It then uploads that contract into the Pact broker. When we build the back end later, the back end will pull that contract down and it will test itself against the contract. If it matches and it works okay, it uploads to the packed broker and says, I work with this front end. And so the packed broker is keeping track of what works with what, and it gives you this little matrix if you want to visualize it. The other thing that it gives you is a function called can I deploy? And what that means is that before you deploy it, it will check with the packed broker whether the front end that you're about to deploy will work with the back end. If it does, it goes green and it lets you through, and it goes all the way up then. So this is great because Pact is managing all the versioning. We're doing all the versioning ourselves. Pact is looking after us to know what goes with what. The end-to-end tests are all running in dev. If there's an issue, it's clear what the issue is because it's just that one commit. There's no release management. We know what version is in what environment because it's all the same. So it's all sounding good. Except this is the part where people on your team might start fully freaking out. Because when it kind of really becomes clear that we actually are going to start hitting production with every commit, it can really cause concern, especially if it's not been done before. And people start asking things like, well, what if someone comes home from a pub and merges something and it goes straight to production? How do you deal with that? And I just wanted to say, it's fine. Monzo Bank were at Fusion a couple of months ago. They said it's fine. It's going to be great. But you do have to look through the risks, and you do have to work out how you can mitigate those risks. And so the first thing we found was making sure that we always use TDD, because if you start with a test, you're not going to forget to put that test in. And if you're doing thin vertical slices, instead of doing one microservice and doing all your tests there, and then the back end and doing all the tests there, you don't forget the pact if you're doing a thin vertical slice through all of them. The other thing to think about is risk. So this isn't the microservice that's paying £220 million out a day. It's just a job search engine. So if something goes really wrong, it's not going to be headline news. The other thing is less changes are less risky. If something does go wrong, it's easy to identify it was that commit, so we can revert it, push it out again. And so that's not too bad. And then also regression lockdown. So what we decided was that because we're doing Scrum, after a developer has finished their work, they can grab a QA and say, these are the tests that we've done to make sure that this story doesn't regress with other changes going through. And the QA can look at them and they might say, actually, you've missed this one, or we're going to do this in the end-to-end test. So the idea was making sure that once that story goes across, it's not going to revert. Visual snapshot testing. So this is where you want to protect that if someone goes and deletes all the CSS, it's not just going to go bam straight into production and people are going to get a fright. So hopefully you can read that, but they're actually pretty simple to set up. So this is, if you've not heard of Cypress, it's just something that drives the browser to do your testing. And so this is a simple test that opens up the job page, checks that a certain things are on the page, and then checks to see if the page looks the same as it did before. So I'll just quickly boot this up to show you. And sometimes you see this, and it's called visual AI and stuff like that, but it's not really very sophisticated. It's just simply looking whether the pixels have changed. And so what you can do with Cypress is you can add it as a plugin using Jest, actually. So if I just open this, it might work. So if you click this test, what it's doing is it will load that test up, and that one that I just shown you, it will kind of fly through. So you saw that it did 2 snapshots there. Well, actually it was really quick, so I'd be impressed if you did see that. But it did 2 snapshots, one at normal width, and then because we're responsive, it squashed it, and it's checking that it's the same. So if I go into here, say, and I'm just going to change the CSS to be blue instead, and if I redo the test, what it will do is it will recheck it. It's seen that it's blue, because you can see at the top it's blue. And it's failed. So if I go into Cypress and bring up the diff, on the left is what it was before, on the right is what I've changed it to, and it's highlighted that it's changed. And that's fine if you need that you do want it blue, you just kind of override it and continue. But it's basically to prevent you from just throwing stuff out to production like that. Graceful degradation is a big one, so if that travel time API goes down, we just revert and use the radial search. Performance, we're using K6, so we just do a tiny little test to make sure that we haven't introduced some sort of performance degradation. Integrity, so we don't change feature toggles in production. We change, because it's a quick pipeline, we can change it in dev and make sure the pipeline tests it all in the same way before it gets there. And fast feedback, so really making sure that our Docker builds, because caching in Docker is actually more harder than it sounds sometimes, but making sure that it is fast and using blue-green deployments instead of rolling updates to keep that thing going faster. And then finally, health smoke checks. So what we found is some people think of a health check like this. So you've got your microservice, something like Nomad will say, "Are you okay?" And it will reply saying, "Yep, I am." It's some sort of TCP check. But you can actually do a lot more. So the first thing we do is check that we can reach all the services that we use. So the address service, the database, Vault and stuff like that. And then further to that, you can actually do little mini tests. So you can make sure that your Lucene search returns a result. You can make sure that what's in Lucene is also in the database. And this is really good because it's testing production basically constantly. And it also means that when you do a new deployment, it will make sure that these kind of basic tests are all green before it allows it to go into live traffic. So we shift left as much as possible, move it out. No one's wondering what feature toggles are enabled because it's the same. No one's having to figure out what version it is, and the developers are tracking it all the way to production and making sure that it's going through. And there's no kind of hotfix branches or anything like that. Expect failure, because even when you go through all this and there's a bug come up, people will say, you know, why didn't that automated test catch the bug and this sort of thing. On Monday we broke production because we decided to encrypt everything and we forgot to put the encryption key into production. So, you know, it went down, but we fixed it quickly, and then we look at it and say, how can we prevent that from happening in future? And just a simple script at the start would stop that. So you can get stronger from it, and you shouldn't freak out if it does start failing. So this is just the beginning of it at the moment. We need more microservices to do provisions and courses and plot claimants through that before they're job ready to go into a job. And obviously, if you're interested in any of that, come and find me afterwards at the pub. But for now, are there any questions? Bearing in mind, I can cancel the state pension if it's too challenging.
Hands up for questions. Ah, we have one at the front. That means I don't have to run.
Hello, absolutely excellent talk. This is, I guess, kind of tangentially related. It's really great to see all of this infrastructure set up. And I saw that you were using React with the government's design system. Have there ever been any thoughts of either having either an open source or a kind of components libraries that local councils, because I'm sure there's a huge number of people who have built these components about 1 billion times in different departments and divisions.
Yeah.
Do you know if there was ever anything about like having a more standardized setup for that in React? Because I know that a few people have been going that way, especially even in the government space, whilst trying to follow this design system, given it's really good.
Yeah, so the existing service is in Nunjux and HTML. So we're kind of one of the ones going in with React. There is, so the Ministry of Justice, they have a React library that they're kind of pushing out at the moment. We didn't use that just because we know that in universal credit, we've got a little bit things that are different to the GDS. And so we didn't want to commit to the Ministry of Justice's system, but they are doing that. And more people, if you look at who's adopting it in the other departments, it's getting more and more popular. So I think we'll eventually move to that model. But yeah, as the React goes more out into the government services, we'll use it more.
Cool. Oh, God, you're going to make me work for this, aren't you? Fat guys, small spaces. Oh, no, it's because the stream needs to know as well. You know what? I'm going to magically disappear and reappear, like magic. And magically I'm back.
Yeah. Now, since it's a public website, and as part of the government rule, like it should be accessible, like from an accessibility standpoint. So what we are doing for the accessibility testing And second, for the visual regression, the snapshot that you're talking about, is there any other tool that you looked into, like whether it's Apply tool or Browser Stack or Pussy? Have you looked into those stuff?
Yeah, okay, so we have implemented accessibility automatic testing into the pipeline, but we're having varying results with it at the moment. So we actually use an external company to like audit the whole app every now and then to make sure that we are hitting the accessibility targets. So we haven't found an automatic tool that does it. They do kind of provide hints, but we're relying on an external service to do the audit for the accessibility. Snapshot testing, so the ones that you mentioned are all paid for, I believe. The one that I showed is the open source kind of Jest one. So because we're trying it, we're using the open source free one, basically. Great.
Oh, it's right in front of me.
Hello. Nice talk and great presentation. My question is, how did you manage to convince the higher up people to let you do it? Because to be honest, it looks like you sort of broke away from the standard things of they were doing things right. So how do you convince those people to let you go crazy and do what you want to do?
Yeah. So it's interesting because when you think of a government department, or when I used to think of a government department, you kind of think they're all kind of running COBOL and they're all running like really old things. But in DWP, people are actually kind of really up for this sort of thing. With the Universe monorepo, they do actually want to get to continuous deployment, but because it's so big and so clunky, there's just a lot of challenges to be able to do it. So coming along as a new microservice, half the battle was won because people were already wanting to do it. And again, going back to the risk profile, this isn't like a big money thing, it's a search engine. If it all goes wrong, it's not going to be too bad. So it's more the risk as well, the acceptance of risk that people were happy with.
Wow, cool. The idea of a search engine, if it goes over, nobody's going to cry. Tell that to Google. Right, thank you very much, Tom. I now do have a spiel. I actually now have the official thing that I was meant to say about DWB, rather than my terrible attempt at the front. So whilst I encourage Rob to come forwards and plug himself in, our next speaker, Rob from Hashicorp, I'll give the spiel. Okay, so for the official spiel, and yes, I am going to read it off because I am terrible at winging this stuff. DWP Digital are driving forward the digital transformation for the Department for Work and Pensions. They opened their office, their Birmingham hub 1 year ago and are already having multi-award-winning team. Congratulations. And they're excited to be supporting Fusion and look forward to being a key part of the local tech scene here in Birmingham. Wow, reading things is hard rather than winging it. Now, we have Rob, who has got way too many things attached to his job title, so I'm definitely going to let him do that for yourself. Are you ready?
I don't think I am. I think my computer's decided to crash, if I'm honest.
Technology, what you going to do?
Yep, it's crashed. It's definitely... it's...
Yeah, I do. Slide of Jim. Just what you want, a laptop that dies when it's coming from a company that does infrastructure for most of the flipping internet.
What's happened when you rely on Apple?
Apple, it's Automagic. Which model is that, 2019 or?
2020.
2020.
Yeah.
So no HDMI on board.
No, I've got my...
Little dicky doodah.
Yes.
Do-do-do-do-do-do-do-do. How does one mimic elevator music whilst we're waiting? If you don't hurry up, Rob, they're going to go to the bar. We're going to lose them. How do people feel about a commercial break?
Yeah, it makes sense.
Alonzi!
Makes sense.
Pardon?
Told ya.
You have a 5-minute break. Please come back for our next talk.
Literally, I just unlocked it.
Better?
I was like, okay, sweet. Plugged it in, and then there you go. Your computer restarted because of a problem.
Is your mic cracked?
Yeah, it should be. I haven't touched the mute.
If I have a conversation here, they hear me in Coventry.
Is that better now? Okay, right, sorry. Sorry? Nah, I just have to rebuild my demo. Just water, please, yeah.
That's cool. Oh, bollocks, where's Ryan? No, because I need to double check which one he wants. Oh, no, it's fine. We've got Ryan, because Ryan needs to look, because we've got a spare here, if he doesn't want it, whilst we can line you up with that one. To be fair, in the terms of conference speaking, this means you're the keynote and the most important one, and you really can't screw up. No, the important thing is that you really can't screw up. Okay. I didn't finish writing my slides before my last talk till 5 minutes beforehand. You're more professional than I am.
Yeah, I just need to.
It's fine, you've got another few minutes.
I've got to rebuild my demo.
Dance, dance, dance.
It's going to take a few minutes. Because it crashed, it killed my demo environment, so I gotta spin it all up again. Literally. It happens. It happens. I bet what's made it crash is all the crappy corporate software that Hashicorp should put on there. Because my laptop doesn't crash. Just saying. No. Sorry, say again? Yeah, there's just fine. Might not even use it, but it's always good just in case I get the drive through it. almost there. Just a couple more minutes. Oh, no, I'm done. I'm just loading. Oh, it's just loaded up. So I am done. So. There we go, I'm ready.
You good?
I am hopefully good.
And survey says... Yeah.
I don't think we're good.
We're good to go again?
I'm not sure, you know.
Oh no, it takes a few moments.
Oh, right, okay, cool.
Hannah? And I know exactly which bunch of people started that. Bloody trolls. Right, so, thank you DWP, thank you Tom, and now, after an entire machine rebuild, as far as I can tell, is Rob from Hashicorp. Enjoy!
Thank you. Is my mic, can everyone hear me? Because this, I don't hear the echo.
This is what happens when I don't run the AV.
Sorry, he's on work experience, forgive him, please. All right, brilliant. Thank you so much, Hannah and the team, for inviting me down here. My name is Rob. I'm from a company called Hashicorp. Has anyone heard of Hashicorp before? Oh, good, we're doing something right. If you haven't, we're the Terraform company, as most people call us. So I'm here today to talk to you about how we can enable secure developer access to our production workloads, right? So we're going to be discussing the problem that most of us as devs or engineers in general have had to face at some point in our careers, right? We're going to be talking about, the talk is called Pushing the Boundary of Nomad. A little play on words. It's to do with a couple of our products, Boundary and Nomad. We'll discuss what that is a little bit later. But really, I should have named this talk, I only have 20 minutes. Because this is a 1-hour talk, which I've had to condense down into 20 minutes. So I will do my best to paint as much context as I can. And in an effort to do that, we're going to build a picture, right? We're going to tell the story that I feel like everyone in this room can somewhat relate to, right? So, my buddy Nick at work, it's his turn to be on call, right? But it's his mother-in-law's birthday, and he says, Rob, can you cover my on-call shift tonight? I say, sure, no problem. What could go wrong, eh? Silly me. It's now 3 a.m. My phone has gone off. Right? Something's gone wrong. There's an outage. And, it's woken up the whole household. My wife is giving me the evils, I'm in trouble. I am in trouble. I've got my goddaughter next door because we're having her for the night. She's woken up, and pretty much I have to try and avoid being in the doghouse. So I have all these problems here. In order to solve those problems, I need to solve this work problem. I need to resolve this outage, right? And for me to do that, I need to access the VM that's on the front-end private subnet, as you can see up there, right? Meaning, do I have to put my clothes on and drive down to the office to be able to access that? Well, preferably not, you know. Well, how am I going to do this? Because there is no public internet access to any workloads that are in any of these private subnets. So, traditionally, how you've probably handled this in the past is you've used the concept of bastions or jump boxes or something like that, right? To anyone that's not familiar with what these things are, I'll explain. So here in our network, what you may have is another VM or something like that, which has a public endpoint, right? So you can access it from a public internet. And the idea is that you SSH or whatever onto that machine, and then once you run it, you jump to wherever it is you need to go, right? That's the concept of a jump box. Some people refer to it as a bastion. There are a few challenges with that, though. The first challenge is this. As an engineer, I am only authorized to access certain workloads within my private subnet, right? I'm not authorized to access everything. But once I'm on the jump box, well, I'm inside the network. I can go wherever I want, right? So that's the first challenge, right? The second challenge is managing identity. So Nick and I often joke that companies that we worked at 10 years ago, I bet I can still get onto their infrastructure because my SSH keys, which have not changed in 10 years, are probably still on their jump boxes, right? It's really cumbersome to manage the life cycle of our employment with a company versus the life cycle of these SSH keys on these jump boxes. So, you know, there are challenges there, and these are all attack vectors. The other approach that people take is a VPN, right? So you jump onto a VPN. And all a VPN does is it creates a secure tunnel from the developer straight into the network, and then the same thing. You can access everything that's within the network, right? So the challenge with the VPN point of view is, number one, VPNs are horrible to work with as a consumer, let alone the network engineers that have to set up and configure these things. But secondly, once I'm connected to the network, I have unrestricted access to all the resources and workloads. When we talk about zero trust, it's the buzzword, but really what we're saying is that we have to assume that the attacker is already inside. We have to assume that our networks are already breached. So, if my boss has pissed me off and I want to get back at them, I'm the attacker now. We always look at the outside and say the threats are outside. This whole castle and moat approach that we've taken traditionally over the last 20 years or so in networking is we trust everything inside our network perimeter and everything outside it is deemed dangerous, right? And that's flawed for so many reasons. And one of them is the disgruntled employee. You know, the threat is not always even a malicious thing. The threat can be an accident, a mistake. I've accidentally done something. We need to put systems in place to protect ourselves from ourselves and the malicious folks out there, right? So, I've given you a lot of the problems. How are we actually going to access that VM? How can we access the database if we need to do that? Well, I'd love to tell you, but I probably should introduce myself properly. My name's Rob. I'm a senior developer advocate at Hashicorp, primarily focused on the secure product line. I'm also the host of the Keeping It Secure Cloud Security podcast. Me and my buddy Adil, we do that. Look us up. We're on SoundCloud, Apple Music, all the big ones, whatever. But let's get to the meat of this, because I only have less than 20 minutes now. Right, so I told you what the problem was. We need to be able to get to our private subnets. We don't want to use anything that has publicly exposed endpoints in there, right? So how we're going to access this infrastructure is using one of our tools that we call Boundary, right? Now, Boundary is a secure session access management tool that we launched, I think, in 2020, I think it is. And it comes in two flavors. It comes in a self-managed flavor, just like you're used to. You spin up a VM or whatever it is, or you run it on Kubernetes, and you manage it yourself. Or you can let us manage it for you using Hashicorp Cloud Platform. Right? It's just a SaaS service, a managed service, where you don't have to take care of all the things that we don't really want to take care of. So if we have a walk through the architecture here, Boundary is made up primarily of two components. It's made up of a controller, which is the brains. This is the thing you log into. This is the thing you request session access via. It's the thing that will assess whether you are authorized to perform a specific action. It's the brains. So you have the controller, and then you have the workers, right? So if you look at this diagram here, in the Hashicorp Cloud Platform layer, you have your boundary controller in red, and then the black squares with the boundary logo inside there are what we call publicly facing workers, right? Now, I'll get to why we need that in a moment. If we go to our private subnets, it could be in our data centers, it could be in our cloud environments, whatever it is, we have boundary workers which are living within those networks as well, right? And essentially, like I said, we do not want to allow public internet access in our private networks. So instead of having an ingress where this boundary worker is almost acting like a jump box, it actually punches out to the HCP workers. So we call this feature multi-hop, right? So essentially, there's no internet access whatsoever. This can even be air-gap environments in any of our private subnets. If you want to access something as a developer, it will create a proxy, almost a reverse proxy in this layer, where it will use the publicly facing boundary worker, which is in HCP, to talk to the boundary worker, which is within a private subnet, but it's doing it the other way around. So it's only egress, not ingress. And it's able to create a reverse proxy tunnel for you to be able to securely access that, right? So I've just put the firewalls inside there just to represent that there is no ingress. It's only egress for that. It's very specific. So that's a much better way of securing your networks. So in order to run these workers, it's just a binary or a Docker image, however you want to consume it, but you do need to give it some configuration. So this is an example config file here. You have details like your cluster ID for your HCP boundary cluster, which I'll give you a bit of a tour of that shortly. Yada, 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 some other connectivity information, but the key thing I'm going to point out here is you need something called a controller-generated activation token, right? This is how the worker can authenticate itself to boundary. When we say authenticate, what we're doing is we are attesting to the identity of that worker. Just like when you log into anything, you are attesting to your identity, to whatever that system is. And you give it a unique piece of information that only you would know in order for the target platform to verify who you are and to verify that you are who you say you are, right? So we need to be able to get this. This is saying controller-generated activation token. There are two ways that we can actually get an activation token. The first way is controller-led. So it's the controller that gives the activation token, and then the worker gives it back to make sure that the authentication is complete. The second way, which is very ugly in my opinion, is the worker-led activation token. Because what happens is if you omit this line here in the config file, when you start the worker up, it will generate an activation token within the logs, and then you have to manually go in and copy and paste that into the boundary controller, and it's just not very automation friendly, right? So controller-led is the way that we are going to go. Now, obviously, if you want to run this as a static binary, you can. I prefer to run my stuff on Kubernetes or Nomad or whatever it is. Matter of fact, let's talk a little bit about Nomad. So Nomad, if anyone is not familiar with it, is a workload scheduler. It's very similar to Kubernetes. The main difference between Nomad and Kubernetes is the entrance price for your workloads to be scheduled by Kubernetes is it must be a containerized workload. You have to create your workloads within a container. Whereas with Nomad, it doesn't have to be. You can run executables, you can run binaries, whatever. It can be Docker containers, whatever you want, right? It's very flexible. And for that reason, I do like Nomad a lot. Not throwing any shade on Kubernetes, that's also pretty cool as well, right? So, if you look at the setup here, as a developer, I submit what we call Nomad jobs. This, if you come from the Kubernetes world, is just like your Kubernetes manifests. It specifies different things, the container image, how much compute you need to give it, memory, all the juice and all the details, right? You submit that to your Nomad server, right? Nomad operates on a server-client kind of basis, right? So the server is the thing that is going to take these Nomad jobs and schedule them on clients. So clients are just compute. And essentially what we're going to do with this boundary worker is we're going to run it as a dynamic workload in Nomad, and we're going to schedule it on one of our clients, right? But the challenge here is we're going to need to find a way to get that controller-led activation token in order for it to start. And if it dies, what happens then? A new one's going to spin up, we need to get another one, right? So how we're going to do this is we're going to use the integration between Nomad clients and Hashicorp Vault. I'm bringing something else into this. So Vault is, for all intents and purposes, a secrets management platform, or in my opinion, it's an identity broker, right? What I mean by that is, if we take a database example, is I could generate a set of credentials on the database and store it in Hashicorp Vault. And anytime an application or a person needs access to that, if they're authorized to, they can read it from Vault. The reason why I call it an identity broker is because instead of doing it that way, what I can do is I can configure a secrets engine, which is a concept within Vault, to broker identity on behalf of that database. So essentially what I do is I configure Vault with some details of how to connect to that database. And every time an authorized person or workload requests a credential, Vault goes to the database, it creates that identity, and it gives it to that individual. The identity is short-lived. It has a time to live associated with it. When that time to live is expired, then Vault goes back to the database and it will delete that identity, thereby revoking it. So it significantly reduces your blast radius, right? That's the high-level elevator kind of talk on Vault, but I had to mention that because we're going to use Vault in this workflow to be able to generate our controller-led activation tokens. So I'm calling them ephemeral workers at the moment. So the way this is going to work is we're going to submit a Nomad job, right? And the Nomad job is going to be for the boundary worker to Nomad itself. And Nomad is going to schedule that on one of its clients, right? Now, the integration isn't actually between the Nomad server. The integration is between the client and Vault itself, right? So what happens is the client is going to turn around and say, okay, I can run this job for you, but I'm going to need these credentials, right? So Vault, can you give me these credentials? So Vault will go to boundary, it will create that token, it will give it to the client, and then the client can start up the job. So let's see this in action. What I might do is mirror my screen because it might just be a bit easier rather than breaking my neck. Or maybe I won't. Sorry, they've updated my Mac, so the interface is very different at the moment, and I can't quite see how. Oh, there we go, display settings. Lovely. Oh, this is a headache. Sorry about this, people. This is what happens when corporate IT makes you force updates on your Mac, and then things change and you don't know where they are. Okay, so I'll just move this up here and I will break my neck because life is just a little bit easier like this. Okay, and then it was easier for you, not for me. I have to go and beg my wife for a massage a bit later on. Okay, cool. So this was the worker-led, this is the boundary worker example config file. If we look at the Vault side of things, essentially we have a couple of components within Vault. We have a secrets engine, which is the thing that brokers the identity and or stores static secrets. We also have things like auth methods as well. So you can log into Vault using whatever identity provider it is that your company is using. You can use a combination of identity providers, right? What we're concerned with today is the secrets engine side of things, right? So we've built a custom plugin. That's the other thing that's brilliant about Vault is it's pluggable. So if whatever platform you're using, there isn't a secrets engine or auth method for it, you can build your own, which is what I've done. I built a boundary secrets engine which is going to generate short-lived activation tokens for boundary workers. So the first thing we want to do is I'll go to my README because I've scripted this all out because I never trust myself. I'm going to copy that. This is very hard to do. And I'll paste that. And all that's doing is it's going to enable the secrets engine within Vault, right? So we'll do that and we get success, right? Let's clear this. So next, we want to configure Vault. So we want to say to Vault, okay, how does it talk to Boundary? We need to give it some connectivity details. We need to give it some authentication details as well. Now, generally speaking, Vault will need highly privileged accounts. If it's going to broker identity on your behalf, it is going to need highly privileged accounts. I know we keep saying zero trust, but at the end of the day, you have to trust something, right? So if you decide the Vault is the thing you're going to trust, you're going to have to just give it these details here, right? So to do that, I have the short command here. So we just writed a config to Vault, and my neck is really hurting. And all we're doing is we're giving it the address of Boundary, a login name, a password, and there's a concept within Boundary of auth methods. Just like Vault, you can have different ones. This is the auth method ID that we want to log into, right? So if I run that in here, success, just clear that off screen. Now, next thing we need to do in Vault is we need to create a Vault role. Typically speaking, a Vault role maps a set of credentials, or sorry, a set of permissions in your target platform to what the user is requesting. For example, if you have a user who should only read information in the database and should never write to it, you can create a Vault role which is read-only. It maps to read-only permissions within that database, right? So we need to create a Vault role. What we're going to do for that here is we're going to write this. And in terms of the secrets engine I've built, right, there's a couple of things. We have TTRs is a feature within all secrets engines and all roles. So this is going to be active for 180 seconds, right? And it can be renewed as many times as you like, up to 3,600 seconds, right? The type of role that we're putting in here is a worker role. This secrets engine, I've actually built it to support two things. It can generate these worker-led activation tokens, or it can generate credentials for Boundary. And we need to give it the scope ID, which you'll see all of that when I show you Boundary itself, right? So I'll just copy that. Ooh. And looks like I'm the one on work experience now because I can't copy and paste. There we go. We'll paste that there. Oh, what's going on? I've messed up my copy paste and I can see where I've messed it up. It's here. Yeah. Let's just delete all of that and we'll go again. Right. Sorry about this, folks. And I've lost my mouse. Where's my mouse gone? Oh, my computer's crashed again. I hope it hasn't. Oh my goodness. I've lost my mouse. Oh, there we go. Found it. False alarm, everyone. Just making sure you're awake. There we go. So we've written a role, right? So now we're in a position to generate these worker credentials, right? So if I run this command, all we're going to do is we're going to read some credentials and we're going to give the worker a name, right? So I'm going to call this worker local worker, right? So in Vault, the way that things work is everything is path-based. Just like if you were to use the API, this would be the same path you'd have in your URL, right? So the CLI that we're using is just an interface over the API. So when we run this, fingers crossed, and I'm having issues with Vault again. There we go, it's not worked. Let's try that again. Copy pasta. Run that, and hopefully it gives us some credentials. And it does. That's the first part. Sorry, house rules. If something works, you have to clap. we have a few pieces of information here. We have a lease ID, which is important if you want to revoke or renew a credential. You have the lease duration, which is 3 minutes. As you can see, the lease is renewable in this, but the key thing is that activation token, right? So with that activation token, we can now start a boundary worker. And I should really probably drag this screen, if I can, where's my mouse gone? Sorry, I need to move my majiggy mouse down here. Here we go. So if I move the screen up here, because you really need to see the UI to kind of see this all come into life. There we go. Fantastic, and I'll just full screen that for a second. Right, so if we go to workers here, you will see there is, I can't quite see. You can see there's a worker there called local worker. That's the one that we've just generated. It's appeared in there. Now it has no connectivity information. It doesn't tell you what version of the binary it's running. It doesn't tell you the IP address of it. The reason is I haven't inputted this into the boundary worker, started it for it to make the whole authentication cycle. And I'm not going to bother doing that because I only have 20 minutes. What I'm going to do is I'm actually going to show you how we can schedule this within Nomad so it does it nicely, and then you can see it all within there, right? So if I come back here, what I can do is I can actually revoke this, right? So if I copy that lease ID, and if I don't do this, by the time the 3 minutes expires, it will revoke it by itself, right? So if I do vault lease revoke, and I paste in that lease ID. Oh, there you go, thank you. See, Tom, I told you, there's always someone in the audience that's going to help you out when you're in trouble. There we go. All revocations have been scheduled. If we go back here and we refresh, you'll see that that has gone, right? So it's like magic. So if we go to, we'll have a look at the Nomad job right now. And I think it's called worker.hcr, right? So this is a Nomad job, right, where we tell it a few things. I'm not going to go too deep into this. I'm just going to point out the most important things to make this work, right? Essentially, we're giving it a disk size of 30 gig, I believe. I don't think you even need it that big. I'm not sure why I did it like that. Nomad has different drivers. I said you don't have to containerize your applications to schedule it in Nomad, right? But you can. So the driver that we're going to use is Docker, because I want to run it as a Docker container. I don't really want to have to run the binary myself, but I can. Because we're using the integration with Vault, we need to tell it what Vault policy this job is going to require. Now, policy is just a set of permissions, right? I was able to read those credentials earlier on because I have permissions to be able to read those things there, and it's a certain policy that allowed that, right? Now, this is going to need permissions of its own, and that's the policy that's required. Now, the most important thing here is this, right? In Nomad, because it has this direct integration with Vault, we can do this thing that we call templating. So this is a template of our boundary configuration file, right? Now, it's given all the details that we need or whatever it is, but the one that it doesn't have inside there is that activation token. So what we're saying is that it should use a secret at this path in Vault, and we have to give it some parameters like a name. So we're giving it the allocation ID in Nomad. Everything's an allocation in Nomad, so it's just the ID of that. And that's what we're going to name it. And whatever it gets back from Vault is going to place it in that stanza over there, right? So that's literally all it's going to do. When it does that, as long as everything is all good, it will start up, and we will now be able to make connections to any workloads that are in our private network using this worker here, right? So if I clear this, and I do nomad run, and I think it's called worker.hcr. If I do that, it should start the job, which it has. If we, well, I didn't mean to do that. If we go here, and we head over to Nomad, we go to jobs, you can see we started a new job there. It's taken its time to start. and I'm wondering why. I hope nothing has gone wrong, seeing as my laptop crashed and I had to rebuild the environment. And let's have a look at the logs. Let's go to standard error. And there's nothing. I wonder why. This is very slow. I'm not really sure what's going on, if that's the internet or if I've broken something on my machine. Basically the goal of this here is we have this API, which is in a private network, and we're going to try to access that. So as soon as this boundary worker starts, which I'm only going to give it a few seconds, if not, I'm going to kill it, and then we'll try again. And I'm really confused as to why it's missing that. So that's the reason why it's missing. So something's broken in my demo since my computer restarted. Should we try and do some live debugging? Yay, nay? I'm seeing no, I'm seeing shakes from the top down here, the big dog. So we don't have time to do that. Something's broken. It's literally, because my laptop restarted, I've probably missed a step somewhere and something has broken. That's just life, that happens, right? But essentially what would have happened is we would have had our worker up and running. We would then be able to use our boundary desktop app or the CLI to make a connection to that API. We would have been able to curl it, and essentially it's just going to use localhost and a port that boundary assigns, and it's just going to use a reverse proxy to be able to access that. So there's no VPNs, there's no jump boxes or bastions, everything is targeted. Once I'm inside the network and I'm on that VM, for example, in order for me to jump to another box, I guess technically speaking it's possible, but you would just put in routing rules that prohibit that, and you would use service mesh for services to talk to one another. I'm really sorry that the demo has broken. It's this crappy laptop that has restarted that's really killed it. But that's the premise of the demo. I think you would probably have more questions if you'd actually seen it work end to end, and I'm really upset about that. But so it goes. So that's kind of the end of what I wanted to show you today, and I'd like to open up the floor for questions.
Yeah, no questions. Are you going to be at the pub afterwards?
No.
No!
I'll go back to
Okay. Who here has taken Rob's Twitter handle or contact information off his slide at the front? Can we do the talk again?
Yeah.
We have scheduling conflicts with National Rail, everybody. This stuff's got to keep moving.
There we go. It's here. And we'll just hit play again.
There we go. Right.
It's really not working today, is it?
No.
So if I just go to...
There's a reason they're called the demo gods. Right,
See, someone
so
didn't sacrifice
people,
the
take photos of this. And then pester the crap out of Rob on the internet to ask all the questions possible.
I promise I will respond, as Hannah will tell you.
So thank you very much, Rob. Vanessa, you're up. So, it turns out there's an entire thing with starting this one, so come on, let's...
You got a live demo?
It's fine. I think Ryan always has a live demo, so there's always a chance for the demo gods to redeem us. Okay, are we good?
I haven't tested this on him before, so...
Oh, God, we're having a completely untested talk. Ah, this is so great. Right.
Hang about.
Is your mic on?
Nope. Oh, it's running. There we go. Yes, I just need to...
On it.
There we go. Hey. Yeah, there we go. Can everyone hear me? I'm going to take that as a yes.
Quiet down. Pipe down. And now...
My costume.
Oh, for God's sakes. You know what? There's a costume as well, it turns out. We go from a demo to a...
This will make sense in a moment.
You're a wizard?
This will make sense.
Okay,
Have patience.
Ladies and gentlemen, this is a first-rate event where everything goes smoothly and things go on time. Ouch. My sworn enemy.
I'll pray for like a train delay. Go on, strikers.
Ladies and gentle germs, Vanessa.
Hey, how are you guys doing? You liking the event so far? Having fun? Brilliant, because I'm about to make you sit through another ChatGPT talk, or your first one, as I may have wildly overestimated the number of ChatGPT talks that would be given since it came out. Well, without any further ado, I will begin first by hijacking this talk and discussing a little bit about myself. I am Vanessa. I am a recent graduate from Aston University, currently working at Majestic, and for my final year project, I had the stupid idea to do some machine learning. I did some NLP, barely worked, and I thought, well, I mean, this knowledge is going to get like shoved in the back of my mind. 10 years from now, when the children are doing all the cool stuff, I'll be like, oh, I was there when it was written. I was there when Transformers became a thing. But fortunately or unfortunately for me, in 2022, actually the year that I graduated, we saw the release of ChatGPT. Now, this has been pretty well received, pretty impressive, and I thought it was quite impressive, so I thought, why shouldn't I? Why shouldn't I capitalize on this and make a lovely talk and subject you all to it? So for anyone fortunate enough to not have had to question their job security, ChatGPT is this AI machine learning chatbot that's been made by OpenAI, and I've actually got a description of it right here. ChatGPT uses advanced machine learning techniques such as deep learning and neural networks to generate human-like responses. It is capable of providing information, giving advice, and engaging in casual conversation. ChatGPT is a cutting-edge technology that is changing the way people interact with machines, and it has many potential applications in fields such as customer service, education, and healthcare. And now if I'd written that, I'd probably get kicked off the copywriting team, but this was actually written by ChatGPT itself. It wrote all that text, which actually is quite impressive, given that a few years ago, we struggled to get AI to write like a few coherent sentences. And I'm not the only one who thinks this. Because if you try to use ChatGPT these days, you'll be greeted with this lovely screen. And you have to stay there and keep refreshing until they finally let you in. So you can ask ChatGPT how you make your bechamel sauce or whatever the heck you're going to do. So I think we can all agree ChatGPT is pretty big and it's pretty smart. But what does that really mean? I think we as programmers tend to imagine these problems as hard-coded logic, hard-coded business logic that you've written in the Java server. So like if sentence pattern matches this, then we run this function, or maybe if this query is of this type, we will run this other routine. But what if, photo op, what if I told you that I could summarize what ChatGPT does using nothing more than this photo? More specifically, this part of this photo. Yes, Fusion goers, I am saying that ChatGPT is nothing more and nothing less than a next word predictor. Now, for us to really understand what I mean by this, we have to look a bit deeper. We have to actually see what machine learning does and how it works, and we have to pop the hood of ChatGPT and see how some of this technology kind of came about and was made. And when we look, we don't see that. When we look underneath, what we see is one of these things, very lovely and confusing unidirectional graph. I won't give you a lecture on how machine learning works today, but just as a quick recap to those who know and introduction to those who don't, what you do is you bang in some numbers here at the beginning, and these will represent, in ChatGPT's case, your query, what you've just put in. Bang in there, And off it plods through this network, through these connections, and these numbers will get multiplied in various ways. They will get summed, more numbers will be added to them. And as we plod through, we come to the end, where the result is what ChatGPT is outputting. So machine learning, to summarize all this, finds this statistical link between what you've inputted and what should be coming out. So your query and what ChatGPT is answering. So all it's doing is taking your question, doing some fancy maths to it, and then out pops this like long sentence. All of this magic happens in here, and if we abstract all of this out, we see this input going into our machine learning model, and out pops our predicted output. And I've got a few more examples if I lost anyone along the way. So we could train a machine learning model to predict the price of houses by giving it some information about them, like, I don't know, house type, maybe size, location, year that we're currently in. And if it's had enough examples from the past, it should be able to predict with some degree of accuracy what the price of a house should be. Or we could show it some photos, some pictures of cats, some pictures of guacamole, and we may ask our machine learning model to classify whether this is cat or guacamole, or I think that's Dame Judi Dench. And all of this is powered by something made by this man. Does anyone know who this man is? Aaron, don't say anything. Anyone know who this man is? Sir Isaac Newton. Aaron, nothing from you. Sir Isaac Newton, or for you maths nerds out there, also this man, bit of contention, bit of maths drama. We're not sure who really came up with this first, and what they came up with is calculus, this magical juice, maths juice, that really helps us train, that really helps us train our machine learning models. And to visualize this, because I have sworn not to put any algorithms or matrices in this talk, I'll simply show you this graph where we've got this statistical model, how our numbers are being multiplied together, and we have how wrong our AI is. So for this, we do need to know like what the correct answer should be when we're feeding stuff into our AI. And we can use calculus to go down this gradient to get a little bit less wrong, and over time what we hope is that we'll plodge down this error by changing our machine learning model's statistical model in its head. We'll plodge on down until we reach like some level of acceptable error. I mean, most likely not going to hit 0, but something within the realms of deployability, let's say. And the way we perform this is by giving it examples, like from earlier. So we know that these are cats and this is guacamole, so we can start feeding this into our AI. We can say, when you see this photo, this is a cat. When you see this photo, it's guacamole. And once it's got enough examples, what we will then do is show it an unseen, previously, photo of a cat. This is my cat. And what we hope is that our AI will be able to predict with some degree of accuracy that this is indeed a cat, not guacamole, not a terrible movie from 2019. If I lost anyone there, just think. We take this randomly initialized AI model, and we turn it into this very highly tuned, very quality AI that makes some really good predictions. And the way we would perform this is using some training. Now, the best part of this talk. We have been granted exclusive access to the dog gym, where we will be observing 3 dogs performing their training routines. And yes, I did draw these all myself. Thank you very much. First, we will be observing the supervised learning dog. And we see it here with a trainer. And what they're doing is having a conversation. Now, what our trainer's trying to train our dog to do, and the dog is a machine learning model in this case, what our trainer is trying to get our dog to learn is a translation problem from English to French. So what we're going to first do as the trainer is we're going to say to our dog a phrase in English, cheese omelette. And then our randomly initialized dog will have a random guess, and it will be absolute gibberish. And we say, okay, that's fine. The real answer is omelette de fromage. And off our dog pops, and it's going to do a bit of thinking. And it's going to do a bit of that gradient descent that we spoke about, and it's get a little bit less wrong. And we're going to repeat this exercise where we say to our dog, cheese omelette. Dog responds with something that's gibberish, slightly less gibberish. And then we're going to correct it again. Dog's going to plod on. It's going to do some of that machine learning. It's going to do some of that calculus, going to get a bit less wrong. And 3 hours later, what we hope is that when we say to our dog, cheese omelette, our dog can correctly predict omelette de fromage. We've reached that acceptable level of error. And we can do this with all kinds of problems. So we can have like a question, how are you? And when our dog reads this, it knows it should say, good, thank you. Or we can have some Bulgarian text here, and we can get our dog to translate it into like various languages. So to capture this as a general case, our model is trained on a set of labeled data, and it's labeled because we have like input, output, and it's taught to predict the correct answer. And now in the unsupervised learning corner of the gym, we see a meme. Our brains are cast back to 2016, a simpler time, when this tweet is posted on the internet. This person claims to have forced a bot to watch 1,000 hours of Olive Garden adverts, and then made that bot generate their own. And while I don't believe that this was possible with the technology available at that time, this is an example of unsupervised learning. It looks a bit similar, doesn't it? We're having another conversation. What our trainer is doing here is quoting a book called The Art of War by Sun Tzu. And they've hidden the last word very, very cruelly from the dog, and they're making it guess. So they say to our dog, all warfare is based on, and our dog has some gibberish to tell us. We correct it, no dog, silly you, deception, and our dog's gonna pop off. And it's going to do some thinking, and it's going to do a bit of that gradient descent again, get a bit less wrong, and we're going to repeat this exercise. Dog says something slightly less gibberish, we correct it, off it pops, and many unbearable hours later, what we see is that when we say this quote to our dog will predict correctly deception. Now, what we've done here is we've just randomly plucked a sequence from a piece of text, and we've hidden the last word in the sequence, and we made our dog guess it. And we can actually do this with a large corpus of text. So we can do all of Wikipedia, which you can download. You can feed that into an AI and make it like learn how to finish this article, essentially. We can give it a bunch of books, a large collection of many books from many places. If you see it, you see it. Or movie scripts. We could feed it all of Shrek. We could feed it song lyrics. We could feed it guitar tabs. Anything that you can shove in this AI, you can teach it how to predict. As a general case, we can sum this up by saying that our model is trained on unlabeled data, and it's taught to predict the next word, the next bit of the sequence. And now this sounds quite similar to supervised learning, actually. So in this context, they're basically the same, except for some like semantic differences. In other contexts, they will be quite possibly wildly different, but we're training language models at the moment. Answer the question, finish the sentence, basically the same thing. Subtle differences will come into play later. And finally, we observe our reinforcement learning dog. This is, ladies and gentlemen, the first dog I drew for this talk. You can probably tell. And this dog's already been taught to speak. This is a clever dog. It's not its first rodeo. And we've asked our dog a question. Who are you? And our dog, being actually a robot in disguise, has said, beep, boop, I'm a robot booper. We don't want our dog to say that. No, we want our dog to sound human. So we say, bad dog. No, wrong. You should not be sounding like that. And our dog's going to get really sad because it's got no treat, and it's going to change its answer. So I might ask it again a bit later. Who are you? And our dog might respond with something far better. I'm a robot. And we say, brilliant, good dog. Have all the treats that I have, because that's the answer that I want you to give. And we'll repeat this process again many, many times, really zoning in on the kinds of outputs that we want our dog to be giving us. Now a bit of audience participation. I know everyone loves this. What was ChatGPT trained with? I've given you 3 different training methods. What do you think? I think I'll get hands up. Hands up for supervised learning. No one. Unsupervised learning. Okay, a lot of you. What about reinforcement learning? A few of you, yeah, okay. Well, actually, you're all right and you're all wrong, because that was a trick question. It was trained with all of them. In the wise words of lyrical genius Hannah Montana, we get the best of all worlds. First, we begin our journey with our randomly initialized new fresh brain AI by doing some unsupervised learning and training this really proficient document completer. So we're gonna say that quote to it, it's gonna guess. And actually, if we take this further into all of the different types of text that we might feed it, we might see this quote being repeated like various times in different ways. So it might be phrased like this: the deception is the basis of, and then we would teach our dog to guess. Or we might feed it this long, long piece of text to get that prediction really precise from our dog. It's got all of this information to work with, so we can really get in there and make a really good guess. And what we've kind of done here is actually distill some knowledge into our model. So our dog now kind of knows that deception and like warfare, there's some kind of link here. And this was written by like some fella that lived God knows how many years ago. What's up with that? And our model will now complete text we've given it. So if we start a Wikipedia article, dog finishes that. If we start part of a book, it's on it. If we want it to write like a recipe maybe it's read a few of those, boom, it's got us covered. But that does not a very good chatbot make, because all it's going to do is try and complete like a Wikipedia article out of your query. So what we can then do is use that supervised learning I spoke about earlier to really fine-tune this like question and answer format. So we, as the trainer, can ask the dog a question. How do I bake a cake? And the dog is going to try and kind of elaborate on that, because like it read some forum from 5 years ago where someone asked this question and they then proceeded to elaborate by saying, well, I want this carrot cheesecake, blah, blah, blah. And we correct our dog. We say, no, dog, I don't want you to finish the sequence of the forum you read before. I want you to answer the question. So we're really changing the way our machine learning is thinking about this problem from like finish the Wikipedia article to have a conversation with me. Like, this is a script you now need to complete. Our model will now answer questions if we do that for long enough. But, as I'm sure we've all seen on Stack Overflow, some people can be very mean and condescending and not fun to talk to, or like books can sound terrible, which probably doesn't appeal to most people. And we want this machine learning model to be very appealing, right? So we can make lots of money. So what we can finally do is use some reinforcement learning to train our dog to talk a little bit more human, a little bit less robot. So we can start asking it questions and giving it treats based on its answers. And we can even teach it stuff like human culture, like memes. I mean, if we say, what is love? Which one do you want your dog to respond with? And if we do this enough times, our dog will end up a little bit like this, saying, how do you do, fellow humans? And when we combine all these, this is my favorite animation I've made. We get a ChatGPT. So, is ChatGPT just a document completer? Is it like completing just this script we've fed into it? What do you think? Are we like in agreement, or do you all think I'm still lying? Can I get like hands up for yes? It is just this document completer. Okay, a few of you believe me. Well, this talk goes on, don't worry. Yes. Yes was the right answer. ChatGPT doesn't know that it's like talking to you. All it's seeing is this script that needs completing, and it's like question from you, answer from it, question from you, answer from it. Maybe like elaborate a little bit on this, and it will learn how to elaborate on this. Because all it sees is this document that needs completion. You don't exist. I don't exist. The script is all. It is all that exists in ChatGPT's brain, and I can prove this because I got a bit mean with ChatGPT. I started like pushing the boundaries a little bit. I gave it half a quote. The print was written in 15, and Surely if ChatGPT was reading our question and really processing it and trying to think, like, how do I answer this? How do I pattern match this question? It might say, well, no, actually, the principle wasn't written in 15. What, are you stupid? It was written in 1516. But without skipping a beat, ChatGPT finishes this date and then, like, adds an author as though speakers didn't change. And okay, maybe we've like trained that into it. Maybe we as people like it when ChatGPT finishes our sentences. Because like with that reinforcement learning, we're teaching it memes. Maybe we've taught it this as well. Okay, well, I then went ahead and started introducing myself as ChatGPT, and you'd think, okay, now you're pushing it a little bit. Okay, Vanessa, calm down. It's going to call you out now. It's going to say, oh, no, you're not ChatGPT, I am. But what we find instead is it just kind of continues. It's like, yeah, I guess I started this sentence. I'm going to finish it. I'm going to finish this sequence. And maybe this was also trained in. Maybe we've taught ChatGPT how to complete this sequence as well. Maybe this is just completing our sentence because that's what we've told it to do when it reads this type of question. Well, I go on. I asked ChatGPT half a question, and like, now this is getting silly, right? Surely ChatGPT will see that that's not a real question. It's going to be like, well, you've not finished this, right? There's more to write here. But what we find instead is that ChatGPT comes up with its own question and then answers it because it's finishing this script. I've started the first part of this script, and it's just carried on. It's been like, okay, so the first part's done, so how would this continue? It comes up with the statistically likeliest answer that it thinks, sorry, the question that it thinks, and then answers that question. And okay, now, this is my favorite one coming up. I fully introduced myself as ChatGPT. And I asked it what it needed assistance with today. And you think, all right, now, okay, this is getting stupid. You've doctored this somehow, haven't you? But no, this was a brand new conversation. And yes, I simply introduced myself as ChatGPT. And you'd think, okay, now it's going to be like, no, you're not ChatGPT, I am. I know how this script goes. This isn't a question. You're trying to trick me. But it instead it took the role of a person. Yeah, we flipped the script, and now it's completing the role of a person. It's asking me questions, and it's like, it's acting all interested. So yeah, I'm going to ask the question again. Is ChatGPT just a word predictor? Can I get a show of hands? Do you guys think it's just following this script, right? Okay, some of you still aren't convinced. Well, unfortunately, I don't have time to go on, but I could. ChatGPT is just a word predictor. And what I hope I've demonstrated here is that it's this really well-trained word predictor that's gone through this super-duper long process of like talking to people and having things explained to it, reading texts. And all of that training lets it do all of that amazing stuff that I read out from the beginning. Do you have time for questions?
Oh my good God, I've never thought I'd ever see late stage capitalism and Miley Cyrus together. We do have time for a couple of questions. Hands up!
There's one very eager.
Oh, when's your train? How long do you have?
I could run.
You one or none?
I could run.
Run. Right, James, there's one at the back.
Not really a question. I just wanted to say I tried the auto-completion for the how would on Model 4, and not to creep anyone out, but the response was, it seems your question is incomplete. Please provide more information or context.
Yeah. So they have been fine-tuning this.
I
did do this like last month.
Yeah.
They've been doing some more of that like reinforcement learning and being like, well, actually, if you see this half question, don't answer it. Maybe that's not what you want. Sometimes you have to get into like a bit of a conversation with it and then do like how would, and it will read the top of the conversation. It will get some context from that. And then the how would will be informed. Well, the way it completes that will be informed then by the stuff that you put above. And it doesn't always work because the outputs it comes up with are a bit randomized. It's some of the like crazy stuff that you get into when you actually look into how a lot of this works.
Yeah, and thanks for the talk. It was awesome.
Oh, thanks for coming.
Huge applause so that Vanessa can run here and get in the distance. Next up, we'll get Ryan going.
There's also a laptop here. I'm trying to unmic myself while I also have like a cosplay outfit.
There we go. Are we good?
We'll see. It depends on whether duplicate display works or not. We'll see. I've got the settings open. Ooh. It's duplicating.
It's recognizing.
Where, hey, duplicate these displays to extend these displays. Ooh.
I see a second screen.
Keep changing. Ooh. And I think if I go...
Hold
Oh, there we are.
Right, Mike, you need to unmute.
Oh, how do I unmute? 1 second, I need to find my thing there. Let me just go over there, select that, FN, F11. There we are. Okay, and the thing is there. How do you unmute?
Muted. There we go. Bing.
Hello, hello.
Ah,
Is this working?
It's working. So, it's time for Ryan, our final speaker. And Vanessa, run!
Cool. Hello, lovely to meet you. I'm Ryan. I know there's a bit of irony on that. I'm not sure if anybody saw the post on Reddit today about the Ryan meetup. Raise your hands if you're called Ryan. I'm not sure how many we have in the audience. Just the one. We're doing apparently the Ryan meetup. Who would have known? Exciting times. So I will steal the stage and introduce myself. Hi, I'm Ryan. I'm the Coderbar Birmingham co-organiser. And I'm also a community-oriented full-stack dev. And I am here today to do a talk on, wait for it, my cool CLI tool. Oh, exciting. What does it do, you might ask? Well, I'm glad you asked. It does. Datafication, gamification, extended reality, synergy, blockchain, agile, SaaS, fast, HTML5 CPU, and it can be yours for the low, low price of running this non-suspicious script. So does anyone want to install it? Want to run it? Okay, let's do our due diligence and actually have a look at what's inside of this script. Okay, so we run a few more shell. Well, that's perfectly understandable if we. Those scripts run more, and oh no, this is. Okay, so a lot of scripts running. Let's calm down and take a step back. How many of you have run something like this in maybe the last week or so? Show of hands. Is that my phone? Oh, no. That was my exact ringtone. You'd have it. Well, that is suspiciously similar to that. And I will show you how in a bit. But first, why might this be a problem? Well, I think that the ratio of dog-related stories in this talk is not high enough. We have only had one talk that includes stories about dogs. So, story time. Oh, when you look at that, it's a dog, very cute. And this dog has a GitHub account. Ooh, it's a normal dog. And as you can see, it's a normal dog. It likes barking at things. And it hosts a website showing various types of dogs. One might say, a dog blog. Ooh. Let's have a look at this dog blog. Oh, look, they're all very cute. However, a dog has a problem. User engagement. Not enough people, not enough likes, not enough clicks. So how do we do that? An idea. How about we add a like button to our website? What could possibly go wrong? So we'll have a look at the layout of the project so far. It's a fairly standard Gatsby React project. You don't really need to know the language, to be honest. Ooh, a zoom in, which I definitely put there. And yeah, fairly standard React. We add some stuff here, and yeah, we've added a like button. So it's got +1. But there's something very dangerous about this code. something that could be catastrophic. We add a number to a variable. What if there's a single event upset? That's right, the sun is a deadly laser. And it could randomly bit flip us. We could have an inaccurate number of lights. This would be disastrous. Our credibility would be ruined. So, well, I mean, you can see even the Denmark government had a problem with this, where somebody got 4,096 extra votes. So it does happen. And as we know, all modern infrastructure is built upon the shoulders of giants. Just don't delete that, please. You'll be in a bad place. So, as we know, NPM has a package for everything. So we'll install, and yeah, let's have a look. Okay, there's apparently a package for Cosmic Ray Safe Edition. I didn't know that either. Yes, it non-suspiciously adds some numbers together. How exciting! Nothing suspicious here. And if we look at the GitHub account, look at this. It's a cat. It definitely doesn't hack things. It loves dogs. And yeah. So we'll run the install command, and look, it gives us a lovely little cute message, and oh, it's adorable. So we install the package. How exciting. We've made sure that we are safe. No cosmic rays here. And look, there it is. Look, he's celebrating. Oh, it's great. He is having the time of his life. So, knowing that we've got our new feature, we can go to sleep. Wake up in the morning, excited to see everything that could have... what has happened? No! Something has gone horrendously wrong. Who let the cat out of the bag? First starting with, how did this happen? Well, if we look at the project again that cat was running, there is a package.json there. This package.json has a very, very, very interesting key in the file. Post install. How many of you have heard of this lovely NPM feature? It's great. Effectively, what it does is it will run a piece of code whenever your package is installed, and it does that recursively, so if you install a few hundred dependencies, there's a few hundred chance for this to run. It's quite exciting, really. And in CI, that message did something that wasn't intended. The nice message had something bad about it, which could have been something like this, where we package up your deployment environment and post it off to a nice web URL, at which stage the cat has your secrets, and bad things will proceed to happen. Oh no. I'm not going to do too much more into this, but there is a cat picture. The bad thing that the cat was doing was something about this cat picture, and you can play about with it yourself at a normal cat. Send me a message if you actually find out how it works. So, who did this? Well, culprit number one, the cat! That's right. What happens if it was actually all lies? If he was a hacker cat, it was suspicious. Bad times are abound. Is this our culprit? Well, there is real-world precedence for this. I think the most well-known case is of Rear Evangelist. I'm not sure if many of you have heard of this story, but as you can see, he's a fairly well-respected member of the free and open source community, and he had a package called Node IPC. I'm not going to go too specific into the reasons for why he did this, but he pushed a malicious package version that would look if your system locale was in Russia or Belarus, and it would delete your entire operating system if you ran it. So that's not good. And this was a well-respected member of the free and open source community, so rather worrying. But there are other possibilities as for why this would happen. For instance, the cat could have been framed. we are running this lovely command. What could possibly go wrong? Can you spot the difference between these two lines? Yes, that's right. There is no A. And that is literally it. If we go back to our packages, well, actually, there's two. And one of them is, well, slightly misspelt, which is not good. It looks very similar, and actually, it even allows you to put in the repository URLs as exactly the same thing. The only difference is that it's ML instead of MAL at the end. So that's sketchy. And this is known as typo squatting, and it's done in a number of different places. I know some of you might have heard of Electron. I don't think so many people have heard of Electorn, and this was a real package that people downloaded, and I think it installed a crypto miner, so not good. This happens with domains as well, which is why if you've ever misspelt a domain at any stage, sometimes it will redirect to the correct place. This is because big companies will actually go out and buy these domains so that if you do mistype something, you get to the correct place instead of a login page for Google, but it's actually Google. You can also aim for the big fish. You can become a maintainer. Look at this. It's probably a normal cat, and he's asking a normal cat, can I become a maintainer on your project? I've seen that people are using it. Keeping cosmic ray safe is critical, after all. And yeah, if we have a look at this, it seems legitimate enough. So let's add him as a maintainer, and we're doomed. The probably normal cat was actually not a normal cat. And this has happened before, and I'm going to go over and actually read my notes because there's some interesting points on here. An example of this was EventStream, which was an incredibly popular JavaScript package that back in 2018, a malicious dependency was added to it. Chris Northwood has an amazing write-up on this, but he is an abridged version. The GitHub account was added, this one, as a maintainer to one of the packages, and they installed another package as a dependency of that package that in itself was malicious, pushed a new version, and ironically, a deprecation warning is how it was found. A little message going, oh, actually, this is slightly out of date. Do you want to have a look at it? Oh, I wonder where that's coming from. Oh, actually, it's a crypto miner. So, yes, bad times abound. And the fallout was fairly widespread, as you can imagine, with 3 million downloads a week. It was quite a endeavor. And I think the last kind of major way that I'm going to go through here is you can compromise one of the maintainers. If we go back to the way that our dog did it, we had a dog with a blog. And that dog installed a package called add some numbers, and that package got compromised and the dog was sad. However, maybe there was an error correction library that the add some numbers cat was using that the dog blog in turn used. And if that package was compromised, everyone who was consuming that one and everyone who was using that one would have also been compromised. And this gets even worse. You have a dependency tree of things that depend on things that depend on things that depend on things that you eventually depend on. And if any one of those gets breached, it begins to get really, really bad very quickly. And to just visualize how big this is, there's a great visualization tool, which I think I have the name of over here. It's a website called Ivanka, and it allows you to visualize all of your node dependencies. And as you can see, there are hundreds of contributors, if not thousands, and hundreds of dependencies in that simple blog website. If any one of them were to be compromised, or you were to consume any compromised package, the entire thing collapses because you've gotten that code on your system and run it. which is less than ideal. And this did happen with an even more high-profile package, 50 million downloads weekly. Huge number of downloads. And yeah, one of the maintainers of that simply had a key that was stolen for publishing to NPM, and a post-install script was added that I think also added a crypto miner. Lots of crypto miners today. But it goes to show that even these big packages aren't safe from these fairly high-profile attacks. And I think, never mind. I'm trying to look at my notes and they've disappeared. Oh well. So I guess the bad actors win. We've lost too many dependencies, too many places to hide, too many things to fight, too many fires to put out. Oh, despair. But how could we avoid some of this? Well, I have some five fairly simple things that you can do to at least mitigate the chances of this happening to you. The biggest one, and the one line that I want you to take home tonight, is you can just tell it to not run scripts. If you don't run scripts, your consumers could have problems. But if you're running code in sensitive contexts and installing stuff in those highly sensitive contexts, then you're liable to this. And 90% of the time, you don't need to run any of these scripts. And if you do need to run these scripts, you can run them individually. For instance, Node Sass. I know sometimes you install it, and you need to compile Sass to actually get it to work. You can run that script separately, given you trust and know that package, and disable it globally for everything else. So please really do take note of this. And all of these dependency managers have their own ways of doing it, but there should be a way in yours. The next is by limiting the amount of access that the scripts actually have at runtime. So if you are installing stuff, there's no point in having your deployment keys there where you're actually installing stuff, because why would you need them there? You only need the dependencies so that you can actually run your deployment script later. For instance, at the top here, we've got a GitHub token that's globally available. So npm CI, which installs everything, will run a billion shell scripts off the internet, and then bad things will happen, unless you run no scripts like we do before. If you split it up, there's going to be no GitHub token when you actually install the packages, or when you build, because you don't need them. Another fairly easy thing to do is to just limit your token scopes. You don't really need to give things access that they don't. It's following the principle of least access. A fairly simple thing to do and very easy to configure from a lot of different places. A lot of services will have fine-grained access control. Make sure you use it. Pinning your dependency versions is another important one. Make sure you use lock files, requirement files, any of the other kind of sequence of lock files, because normally these vulnerabilities appear when you have a new vulnerable version pushed. If you're locking all of your dependencies, you're not going to jump to that new version immediately. You're just going to stay on the old safe version. And finally, just like use SNCC or other similar tooling that allows you to audit your packages and try and at least realize the vulnerabilities that you have within your packages whenever they appear. Closing notes. I love open source software. This is not a riff on that. There are 2 million packages, and I think even more given this was written a little while ago. And only a couple of thousand of them have been kind of found to be these vulnerable packages or packages with intentional exploits pushed to them. And through the tireless work of all of these maintainers, the internet basically runs. So it's very appreciated. And cats can get on with dogs. Look at that. Handshake. Thank you very much for having me. Thank you very much, Fusion, and TechMids for all of the support. You can find me on ryan.gd, and the slides are on ryanoli/talks. Let's all go to the pub.
Oh, I'm too old for this. Any questions for Ryan before we go to the pub? Because I know some of you will disappear afterwards. Hands up! Wow, that cough made it weird. Anybody? No? Okay. That makes life easier. Because I was going to say, how about recommending insert technology at the end, renovate Snickers? Like, you've already done it. Damn it. Okay, then. It appears that's the end of the day. Thank you very much, everybody. So, I believe I'm meant to do the closing note thing as well? Yeah. So, thank you, everybody, for turning up. It wouldn't be any use if we did this to an empty room. So, thanks. We also have to say thank you to our speakers, of which I've just been given a note that is Vanessa in the room still, or is she?
Did she get to try?
She did not. No, it's good.
Oh.
Somebody's driving Vanessa back. So if you want to ask about dogs, machine learning, or whatever the hell guacamole came out of her brain, feel free to ask her at the pub. Questions can be had. But yes, so. Yeah, we can go to the pub in a minute. It's fine. I've got to say thank you to our sponsors. So Infobit T-shirt. Thank you to our other sponsor, DWP. And thank you very much to the organisers who've put everything together, because surprisingly this is a lot of work. So thank you, Hannah, Andy, and everybody else. Great job. Now, we're going to go to the Cozy Club. Who knows where that is? Right, if you don't know, follow one of those hands. If not, I'm going to be really loud and shove everybody along in a moment. So, thank you very much for turning up. There's all the events that we had at the beginning happening in the next couple of months, and we'll be back in summer? Summer, yeah, so keep an eye for that. So, thank you, and good night!
Can I... Is that muted?
Won't be the last time.